Yeah, hi guys. My name is Chintan, and today we are going to actually talk about networking. So, when we talk about networking, right, networking is one of the very important aspect in multiple domains. So, no matter in which domain you are, networking is very much important. Okay, you might not know, but networking is actually being used everywhere in every other domain that we have. Okay, from which whether from cloud to AI to generative AI or any other domain that you know, okay, that you have come across. So without wasting the time, let's directly jump into the topic. Okay, so before starting the class, I just want to request all of you to please like and subscribe my channel, and if you want, you can also comment on my videos, so that your like and subscribe will actually help me a lot, and it will give me the motivation to keep on creating such informative videos, right? So without wasting the time, let's now talk about the networking. Okay, so what is a network, right? What is a network? So whenever two device wants to talk with each other, okay, we always need some kind of a physical connectivity between both of these devices. Okay, say that this is device A and device B. Okay, and if both of them wants to talk with each other, so we always need some kind of a physical connectivity. Okay, so that they will be able to talk with each other, and that physical connectivity could be either wired or it could also be wireless, right? It could also called be wireless. So during the time of your college days or everything, you might have heard about the term called topologies, right? So what is meaning of topology? So the moment when we talk about the topologies, it is actually a way to basically organize multiple devices, okay, so that they can communicate with each other to actually send and receive the data packets, okay, to send and receive the data packets. So it's just a way of organizing out your devices. Okay, there's nothing much. So that is what is actually called as network topologies. Topologies, from the automatically, I think in your geography also, you might have heard about the term topology, right? So if you see the literate meaning of topology, it is just a way of organizing out the things in such a way that it actually creates some kind of a meaningful impact. In the same way, when we talk about the networking topology, it is just basically a way to connect your multiple devices within your particular network so that they can communicate with each other. Okay, so even when we say, when we are taking two devices and we connect them with a wire, with a real physical wire called the Ethernet cable. Okay, so this kind of a topology is called a single topology. Means there are only two devices which is actually having a dedicated wire, okay, connected with each other, and they actually form a network called a single topology. Now both the devices can actually receive the data packet and they can send the data packet. This is actually called as a private network. Okay, that means both of the devices is actually being in private in world. Okay, so both of them are actually private in the world. So both of the device can now directly communicate with each other through this dedicated line. Similarly, when we talk about internet, okay, so when we talk about the internet, what is internet, right? So internet is actually a collection of different kind of a network, collection of different kind of a network. Okay, internet is a collection of different kind of network. Okay, so now you might be thinking, so in your home, when you are actually using the mobile Wi-Fi, or when you are using the sorry, I mean to say mobile hotspot, or when you are using the mobile Wi-Fi, right? Mobile Wi-Fi, those are two independent networks. Okay, one of the mobile hotspot and other is the Wi-Fi, that is which you are actually using. See, in my laptop, I'm currently using my Wi-Fi, right? So both of this mobile hotspot and Wi-Fi, both are two different networks. Okay, both are two different network being provided by some kind of a provider, and they are actually providing one kind of a service. Okay, that is internet. Okay, and that is the reason why companies like Geo, Airtel are also called as your internet service provider, because they are actually providing you the internet as a service. Okay, and for which they are actually charging you. Okay, Now the moment when we talk about the internet service provider, similarly when we talk about this in terms of the cloud, companies like AWS and AWS and Microsoft, okay, they also provide you the facility to create your own particular network, which is very much, which is equivalent to the similar to the Wi-Fi that you are actually using in your home. There is no difference between both of them. Okay, both of them is equal. It is 95% I can say it is same. There is only 5% difference that when you take a Wi-Fi connection in your home, okay, your internet service provider is actually configuring all your networking configuration for you. But in case of AWS and Microsoft, right, when you go to AWS, that is the product of Amazon, and when you go to the Azure, which is the product of the Microsoft, okay, there you are actually configuring your particular network. So in case of AWS, we call that is VPC. We call that as VPC, and in case of Microsoft, we basically call this as Azure. Okay. Now let us understand what is a network. Okay. So as I told you, so when we talk about VPC, that is the virtual private cloud or virtual network. So what that, and when we talk about the whole network, VPC, VNet, or home network, that is your Wi-Fi. Okay, all of them are same. So what happens is there is something called what they do is, so whenever you request for an internet connection in your home, so what your internet service provider does is they actually provide you one kind of a device. Okay, that device is also known as router. Okay, and what is happening in this particular router, they have actually configured a CIDR range for you. CIDR means for the time, CIDR means uh, so as you know, currently any number which can actually be stored in 32 bits, okay, is called as a valid IP. Okay, it's called as a valid IP. That means if you convert this bigger whole number into a binary number, you will actually get a 32 bits number where one byte equals to 8 bits. Okay, that means in an IP address, we are actually storing the 4 bytes of data. That means 8 into 4 equals to 32 bits. That is the reason any number that can be stored within the range of 0 to 255, 0 to 255, and 0 to 255, and 0 to 255 is a valid IP. Okay, so if you try to create a particular IP address or a range that is beyond this particular range, that is 0 to 255, then then you will never be able to create your network. Okay, so what is happening is, so whenever you request for an internet connection from your internet service provider, they actually configured a CIDR range for you, that is also called as class inter domain routing. Class inter domain routing. Okay, and this class inter domain routing is nothing but it is just a way to create how many number of IPs you can create within your network. In the simple manner, if I try to make you understand this one, okay, you can think in this way that when I'm writing like 192.168.0.0/16, okay, this slash 16 is called as a where we are actually reserving the first 16 bit out of the 32 bits as the network name. Okay, as the network name, and the other 16 bit, we are actually reserving as a host IP. Okay, other 16 bit we are actually reserving as a host IP. That means from the 32 minus 16, if you do, equals to 16. That means 2 to the power 16, if you do, it will come to somewhere around 65,536. Okay, that means this many number of IPs we can actually launch within your network. Okay, but this IP configuration, this CIDR configuration, when you create VNet or VPC, we have to do. But in case of a router or in case of Wi-Fi, automatically this is actually being done with us. Okay, in the network there is a concept called as net masking. Okay, that means when we store this number, that is 255.255. Okay, if we are reserving this first 2 bit for the identification of our network name. Okay, we are actually reserving this first 2 bit as our network name. Okay, and whatever the rest to IPs that we have, we are actually trying to create the number of IPs with this. This is also called as net mask. Okay, so whatever you term you see about the net masking, and this particular thing is also called as net mask. Okay, now if you see in my laptop what I will talk about. Okay, netmask is just if I type the command ipconfig, right? You see, currently I'm connected to my IP, and this is the this is the mask, this is the network mask that I have. That means 255.255.255. This 3 bit, so that is the first 3 byte I can say has been actually reserved for my network name identification. You can think that similar to like when you talk about the mobile numbers, right? When we say any number that actually start with, suppose just a hypothetical example, any number that any first 10 digit number that start with 92 belongs to Airtel, right? Any number that actually says 90 that start with 94, any first 10 digit any 10 digit number whose first two prefix are 94 belongs to the Reliance, right? So in this way, so we can identify any number that start with 92 is a Reliance company number. Any number that start with the 92 belongs to the Airtel number. In the similar way, so how can we identify that our IP address belongs to which particular network, right? So in that is the reason why we actually segregate our IPs into two parts, that is the network name and the host name. Okay, just to identify what is the network name of our particular network. Okay, so that is what is called a subnet. And how can we identify this? We can actually identify this subnet mask. That is, we can identify through it masking. That means we have already reserved, that is 0 to 255. That means we have already reserved 255.255 as the network name, and the remaining 2 bits as my host name. So that is what I have shown you over here. Okay, I hope you might have understood the meaning of the term. Now let us take now let us jump to what do you mean by a home network, VNet, VPC, and all. So what happened? In your particular network, when you request for the internet connection, right? So what is happening is your internet service provider creates a CIDR range for you, that is 192.168.0.0/16. Okay, and what they do is they further divide your bigger networks into smaller networks. Okay, so this is one of the network that you see currently, which you will see will actually become a part of internet. Okay, so what is an internet? It is a collection of different kind of multiple networks becomes an internet. Internet is nothing but it is just a simple collection of different types of network in that you see in the whole world becomes an internet. Okay, so what your internet service provider do is they actually create multiple subnets for you. Okay, so they divide your bigger network into smaller network, which are also known as subnet. So if I say subnet, so there is nothing like you cannot create subnet, you can create multiple subnet. Even one of your bigger network itself is also a subnet in itself. If I want, I cannot, if I want, I can actually delete this entire subnet. There is no need of having this particular subnet 1 and subnet 2. It is just a way to actually segregate. It is just a way I can say to basically distribute your number of IPs. Okay, just to distribute the number of IP into smaller networks. Okay, it is just a way to distribute your number into smaller network known as subnet. Now you'll be so what we do is, and even for this particular subnet, what we do is we actually give the CIDR range out from this particular bigger number. That means suppose if I have given 192.168.1.0/24 equals, that /24 here means 32 minus 24 equals to 2 to the power 8. That means somewhere we can store round about 2 to the power 8, right? So 2 to the power 8 will come to around, one second, give me a, let me calculate this. 2 to power 8. 2 to the power 8, which comes to around 256 IPs. That means we can launch somewhere around 256 IPs in this particular small subnet. That means 256 devices can be launched in our subnet 1. Okay, so when we talk about subnet 1, okay, this is nothing but it is we are actually dividing our network, bigger network into multiple smaller network known as subnets. Okay, this is subnet 1, this is subnet 2. Okay, this is subnet 2, and whatever the IPs that actually get assigned to each of the devices being launched within this particular network, okay, is a private IP. So actually in the internet there are two, in the internet I can say, if I talk about the internet, right? So if I talk about the internet, there are two types of IPs. One is the private IP. Okay, in the internet world, there are, or in the networking world, I can say there are two types of IPs. One is the private IP and other is the public IP. Okay, remember always one thing, you can never connect to any IP, you can never connect to any device which is actually having a private IP, because it is private to your network, and you can only connect to any device in this within this whole world, only if you are have only if that particular device has a public IP, and public IP is always chargeable. Okay, this public IP never comes for free. Okay, so in the internet, whenever we talk about multiple network, each of the network, if one of the device wants to communicate with the other device directly without any intermediate devices, okay, wirelessly, okay, or wired, okay, there needs to be, so we need actually a public IP to connect with any remote computers. So right now, my device, so if you want to connect, if you from your laptop, if you want to connect with my laptop directly via some kind of a remote connection, then I need to have a public IP assigned to my device. Only then I'll be able to connect with my, only then you'll be able to connect with me. Okay, so now let us take now let us understand what is a private IP and public IP. Okay. Now when we talk about the subnet, right? These are here also we actually create some kind of a range. So how many, that is 256. How will assign the IP? So what are the IP that will actually get assigned with something like 192.168.1.1, 192.168.1.2, 192.168.1.3 up to how much? 192.168.1.255. Okay, that means we can actually launch how much? We can actually launch up to 256 devices, which include 1.0 includes the subnet range. So 0 to 255 equivalent to 256 devices. That means from this particular bigger number, out of 65,536, minus 256, we have already detected few number of IPs by dividing a bigger network into smaller number. That means it will come to somewhere around 65,536 minus 256 equals to 65,280. 65,280 IPs are left inside this particular network. Okay, similarly in the subnet 2 also we actually define the CIDR range of it, something like this. Okay, that means here also we can launch somewhere around 256 devices. Okay, and this 256 devices will again get subtracted from this entire bigger number, equal to how many IPs will be left. Okay, that is 65,280 minus 256 equals to 65,024. This many IPs are still left. Okay, and this could be a third sum. Okay, so there is nothing as such, there is no limitation of how many subnets you want to create. Now what happens is, in your internet, so whatever this configuration subnet and all that you see, in case of your home network, everything is actually pre-configured in case of our home network. But if you see, we already have the subnet and everything. So currently if you see, I'm actually having this IP address that is assigned to me. That means whatever the IP that you see over here, each of these IPs are actually, whatever the IP that actually gets assigned to your particular device is a private IP. That means nobody from the outside world can actually can directly communicate to this particular devices. Why? Because they are private IPs, right? Even whatever the IPs that you actually see, right? They are also having the private IPs. And there is a and what happened is, there is a device in your network which is actually called as a switch. The only use case of this switch, is to basically help in communicating between multiple devices within the same network. That means suppose whenever suppose if this device want to communicate with this particular device within the same network, any network packet that actually any traffic that I can, the moment when I say traffic or data packet means the same thing. Okay, so any traffic that gets originated from this particular device, all the communication within the devices, if they belong to the same network, will always travel through switch and will always go and or will always come back through the switch only. Okay, so even if you even you know even so by default what happens is, so both of the devices are connected to the same network. That means suppose you can think this as my this particular whole bigger network as my Wi-Fi, right? So you can think this is my smart TV, this is my one mobile phone, this is my laptop, this is my other laptop. Similarly, I'm having few more multiple laptops each with each other, right? So whatever, suppose whenever I try to ping is actually a command. Okay, ping is actually a command to check the network connectivity between two devices. Okay, and whatever the IP that is actually getting assigned to this, who assign this particular private IP to each of the devices. So here the role of DSCP CV server come into play. Okay, so DSCP server is so the only duty of the DSCP server is to basically assign the private IP to all the devices within this particular whole bigger single network. Okay, so whatever the IP that is actually getting assigned to each of them is getting assigned due to the DSCP server, and there is something known as a route table in each of the devices. Okay, in each of the devices that is also being created by your DSCP server only. Okay, and route I what happens now, suppose if you remove this particular device and connect with some other Wi-Fi, then whatever the private IP that actually gets assigned for that particular network will be the private IP of that particular network, not this particular network. I hope you understand the meaning of the private IP by now. Okay, so going understand now what happens is there is a something there is one more device which I told you, right? Router. You know what? Router is also called as an internet gateway. Okay, router is also called as an internet gateway or bridge. That means it is actually acting as a kind of a it is actually acting as a kind of a bridge between the outside network internet internet and from and your network. So it is acting as a kind of a bridge between your network and a and the internet. Okay, so you can also think in this way that suppose if one of the device suppose if one of the device actually wants to go to the internet, how they will go is, okay, they will always connect through the switch and then switch to the router and then router to the outside world. Okay, now here the role of public IP come into play. Say suppose this particular device wants to connect with www.google.com, right? www.google.com. So what will happen is our network packet gets generated from these particular devices. Okay, and then it connect to the switch and then to the router, and from the router to the outside world. Okay, this is what is being happening. And so what is happening is a router has a two type of IP. One is the private IP, which is actually being used to talk to the uh, all the devices within this particular network, right? And router also has a public IP. Okay, otherwise how will my uh, Google guys will come to know to which particular network out of this whole big network in the internet we need to connect it, right? So it is because of the public IP. Okay, now you understand that why I told you public IP is chargeable. So you guys might be thinking that you are actually paying to your internet service providers for the subscription, internet subscription that you are buying. Say suppose it is of 200, 300, 400. No, you are actually not paying for the you are actually not paying for the subscription. You are actually paying for this particular public IP. Okay, why? Because even your internet service providers are also buying that particular public IP. So that is the reason why even when you create a virtual network in Azure, when you create a virtual private cloud in AWS, they always charge you for the public IP. Public IP is never free. Okay, obviously your internet service providers also buys some kind of a public IP. Okay, so that is the reason why all the devices within this particular whole bigger network, if they want to connect to the outside world, there has to be some kind of a gateway or some kind of a bridge through which they can connect to the outside world. So that is the reason why a router is also known as an internet gateway. You can also think in your like this. That means it is a kind of a house over here, and this is the main gate of your house. Okay. What if if I close this particular main gate, nobody from the outside world can come and communicate to you, and nobody from the inside world can also go out. Okay, so that is the reason why router is also called as an internet gateway. Okay, and when suppose this device, as I said that suppose this device wants to go to the google.com, right? Now google.com will obviously they will also response you back. So even the response also comes to the come to the router, then to the router to the switch, and then from switch to this particular devices. Okay, and even if this device wants to talk with this particular device, all the communication between both the devices in both the subnet or in any other subnet, right, they will always communicate via switch. This is the duty of the switch. That means by default switch is actually used for the internal connectivity between each of the devices, and also for any kind of network traffic outside of your network also. So the moment when you assign the public, so the moment when the public IP get assigned to your particular network, automatically your network also becomes a part of the internet. So that's how your multiple networks are actually working. Okay, now what is happening is, I let me tell you one more thing. Okay, mm, 1 minute, please. Uh, so let me just clean my board first. Okay, let me clean my board. And now you must be thinking one more thing, right? So as I told you that suppose this is your big network, and in this particular network you are having two subnets. Okay, and this is your router, this is your switch, right? As I told you, and there are multiple devices being launched with the network, right? So as I told you, suppose if one of the device want to go to www.google.com, right? Say one of the device want to go to www.google.com. So how does your device comes to know where does it has to go? As I told you, there is something called as route table. Okay, similarly, and this route table creation and the creation of the route table and the entry inside that is actually done by your DHCP server, right? You see, I will show you that currently I'm connected to my Wi-Fi in my home, and if you see the route table of my network, you see what is the meaning of this particular line, right? So whatever the meaning of this particular line is that currently the source, that is the source from where the traffic has to be originated, is my laptop. Okay, and this is one of the private IP that is actually been assigned from my laptop because I'm currently connected to my internet. Okay, so whatever this IP that is actually getting assigned to my laptop is because of I am connecting to my Wi-Fi. Suppose now if I turn off my Wi-Fi and if I connect my phone hotspot, automatically my mobile hotspot is a completely a different network. And suppose when I connect to my mobile hotspot, automatically a new IP get assigned to this particular device, that is my laptop. Why? Because now I am connected to my mobile network. Okay, so the moment when you turn on the hotspot, your mobile itself start acting as a router, as a switch, as a DHCP server, and others. Okay, now what is happening is there is something called as DNS server in your there is something called as a DNS server within that particular box that you see, right? That's there is something called as a DNS server, and this DNS server is also called as a local DNS server. Okay, so the moment when you type www.google.com, so what happens is your DNS server actually connect with some kind of a intermittent DNS server. Say it could be your internet service provider DNS server, internet service provider local DNS server. They might have established some kind of a local DNS server, right? And in this kind of a local DNS server, they might have some created some kind of a record, something like google.com, right? Google.com. I want to connect with google.com. Right. So what this google.com will do is one more thing. So the moment when you talk about www.google.com, right? So behind this particular google.com is nothing but it is a public IP that is actually running behind this particular domain, because as a human can never understand can never understand a number. So that is the reason we always give a name to that particular public IP. That means the moment when you hit any kind of a network traffic that hits to the www.google.com, automatically the traffic is forwarded to your public IP. I can prove you also one of the public IP of the Google is 8.8.8. Okay, 8.8.8. This is one of the public IP of the Google. If I try to ping from my laptop just to take the network connectivity, you see, I'm able to ping to my laptop. I'm able to ping to the Google's IP. Okay, there is also a command to basically check what is the public IP of the google.com. Okay, so what do you think that that your entire Google application might be running in one server? No, there are multiple servers. So server, if I say server or a computer, server if I say or computer, exactly means the same thing. There is no difference between them. As I told you, this is also each server is having its own RAM, CPU, hard disk. All the server will have. This is also called as compute devices, right? Similarly, RAM, CPU devices will have multiple servers will have their compute devices, right? And your google.com is actually running in this multiple servers, right? So whenever you hit www.google.com, now google.com might have multiple public IPs along with them. And one of the IPs I told you is 8.8.8. So there is a complete different aspect how the network traffic gets segregated between both of them, between all of them. It's a kind of a load balancer. They are using some kind of a load balancer. Okay. And they are somehow trying to balance the load, and there could be multiple other public IPs. So let's not get into them. Let's completely, you can assume as of now that the moment when you type www.google.com, it is connecting to the public IP of the Google. Okay, and this public IP is actually assigned to the server where your google.com is actually hosted. Okay, so this is called as a domain name. This is called as a domain name, and Google must have bought this particular domain name from some kind of a companies which actually provided domain name. One of the company that provided domain name already most of you know is GoDaddy. Right, GoDaddy is one of the domain register who gives you the domain name. Okay, other is Route 53 is one of the service in AWS from where you can buy domains. So there are several other companies as well similar to like this now. Okay, so what happened when the moment when you write www.google.com, what has happened? There is actually a server that is actually running inside your box. Okay, that is called your local DNS server. What the local DNS server goes and connect to this particular your internet service provider DNS server or some other DNS server or some other company or something. Okay, and from there we first this particular information. Okay, I want to connect to the google.com, and also you give me the this google.com particular public IP, and this particular public IP will go to some kind of a different kind of they will actually hit to the google.com master DNS server. Okay, this will actually hit to the Google actual master server. Okay, where they will be caching all this information. Means where they will keeping all this information. That means where they will be keeping this information. That means google.com, and suppose this is one of the public IP of the google.com. So they will be keeping this kind of information in their master DNS server. Okay, so now what happened? Your this particular information will be fetched from the master DNS server by your internet service DNS server, and this information will again come and get cached to your local DNS server. Okay, and your google.com decide uh, the moment when I talk about the cache, right? That for how much amount of time this particular information need to be stored within your Wi-Fi is actually decided by the company or by the website who is hosting that particular website. So that is also called as time to live. That is time to live means time to live. That means how much amount of time this particular information should stay in any of the particular device in the device is being decided by the master DNS server, which is also called as the time to live. Okay, if you see the example of this TTL, right? This is actually called as time to leave. Okay, and this the moment when I'm hitting ping 8.8.8, So this entire information is being cached locally. So that is the reason why if you see the moment when one of the network packet generated, it takes somewhere of 53 seconds. Now see, now the seconds are actually getting decreased. Why? Because this information is getting cached locally. Now your DNS now what is happening is your router does not have to go to this internet server. They are directly hitting to the DNS servers of your google.com. Okay, they are directly hitting. Now after say some amount of seconds, say suppose Google might have decided that the information needs to be cached only for say I can say for 60 seconds. After 60 seconds, again your local DNS server will go and cache this information and will bring it back to your DNS server. And then what your router will do is router will take the router will suppose will take this information, will look for this information and will hit to the google.com, and then it will bring this particular response back from the Google to the switch and then to your router. This is how your entire internet traffic actually functions. Okay, and let me show you. If you want to know what is the public IP of your router, how can you check that one? Okay, let me show you. In the browser, if you type what is my IP, okay, if you open this particular website, you see this particular website will show you the public IP of yours. This is the public IP of my Wi-Fi. Okay, so I am actually paying to my internet service provider for this particular public IP. Okay, and you can also confirm with this. I think most of you might guys might be using the speedtest.net, right? To actually identify what is the network speed of your particular Wi-Fi or your I think your mobile hotspot, right? You see whatever the IP address that you actually that you are actually seeing over here. Okay, you see both the I can say both the IPs are exactly 49.37.72.62 and 49.37.72.62. Okay, and the moment what is happening, speedtest.net is also having a public IP. Okay, behind the scene, the speedtest.net is also having a public IP. As I already told you before, like www.google.com is having a public IP. Similarly, your speedtest.net is also having a public IP. I can prove you there is a one command through which if you want you can also check the public IP of speedtest.net. I think that command is something as uh, command to check the public IP. I think it is something as netscope or something. Not netscope, I can say nslookup. Yeah, there is one command that is known as nslookup. Nslookup is the command to which you can actually check the public IP of any particular browser. Okay, you see the moment when I say to see this is the public IP of the speedtest.net. Okay, that means what speedtest.net website is doing. So behind this particular whole big domain, this is the public IP of the that website. Similarly, if you see google.com also has a public IP that is assigned to that particular domain, and this is one of the public IP of the Google. Okay, so now if you try to ping this particular public IPs, you will see this particular public IPs will be pingable. Okay, you see these public IPs are pingable. Even if I try to ping from here, okay, you see if I try to ping here, it is always pingable. Okay, this is just a ping is actually a command in the networking world, which is actually used to test the connectivity between two devices. So even you see even when I was trying to click on go, what they were doing is this particular website was actually trying to hit to my router. You see, even behind the scene, they were also using the ping command. Okay, to check the network speed of my router. That means now what is happening now, combining the whole of this, you are not paying for the public, you are not paying for the subscription. Instead, you are actually paying for the public IP of your router, as well as how much amount of data do you want to download from the internet, that is called your download speed, and how much data do you want to upload to the internet is called your upload speed. Okay, so you are never paying for that fancy subscription which your internet service provider gives. You are always paying for this particular combination. That means you are always paying for the public IP. That is the reason why it is always said public IP is always chargeable. Even so, that is the reason why when you create a VNet or when you create a VPC, so the moment when you assign a so when you create that thing, and the moment when you assign the in public IP, automatically your internet traffic start flowing onto that particular big whole network. Okay, that means what I mean to say, let me just conclude out this thing. Okay, that means whenever you create a VNet or whenever you create a VPC in AWS, what is happening is the moment when you assign a public IP, automatically what is happening is the internet traffic start flowing to your devices that or to your services being launched in case of clouds. Okay. And when you talk about the home networking, what is this particular whole thing? The moment when I say router, so the moment when I talk about this box is a combination of multiple type of devices. Okay, this device has a DHCP server, this device has a switch, this device has a router, this device has a DNS server. Okay, now one more thing. So your internet traffic, okay, your internet, your wireless is only till this much. Okay, after that you might have seen there is a something called an Ethernet cable that is actually connected to this particular box of yours. So your internet traffic, that means what is happening, there is a device called as modem which converts your digital signal into analog signal, and with the speed of this particular light, the data travels through this high fiber optic fiber cable. Okay, and then it's using the public IP of the destination that you want to connect to, say google.com. It actually hit to the server of that. So your internet is nothing but it is just a wired connection only at the end. If you see, that means your wireless is only till this much, but from here your internet is actually traveling with the speed of a light. Okay, speed of a light, and it is hitting to this particular devices that you want to connect to. Okay, and as I told you, there is in each of your devices, I told you there is something as a route table, and that particular route table entry, you see the meaning of this particular line is this, that from this particular device from which I am currently teaching you, right, or from which I am delivering you, if you want to connect to any network in this whole world, you will always have to travel through a gateway, that is your router. Okay, otherwise how will your device will come to know from where, from which particular medium bus it needs to send out the packets, that is the network packets. Okay, so it is actually happening because of this particular route table. If I delete this particular route table, no, there is a command to delete this route table. Even though if I have the internet connectivity, I will never be able to communicate to the outside world. Okay, I'll never be able to communicate with the outside cloud. There's a command called the route del. Okay, there's command something like route del through which you can delete your this particular network. And one more thing, your private IP, that whatever is actually getting assigned, it is actually getting assigned to one of your real physical device within your laptop or within your computer. Okay, that is called as network interface card. Okay, that is actually called as a network. So the device, the real physical device, is called as a network interface card. Network interface card, that is also called as a NIC card or Ethernet card. Okay, so this is the reason why whenever you launch an Azure VM or VPC, so the moment when you launch these particular VMs inside the virtual network, you will see automatically a NIC card also get created. Okay, and NIC card is nothing but it is actually a private IP. Okay, you will see that whenever the moment when you create a VM and you assign it to the particular VNet, when you launch, automatically a NIC card also get it. So whatever this private IP is getting assigned, it is actually getting assigned to a network interface card, because this network interface card is connected to your network. Okay, so when you talk about VM or when you talk about computer, both work the same way only. The only difference is that you are working, that is, you are actually working in the virtual environment and your laptop is a physical device. Okay, but the functionality of both the devices is exactly same. Okay, and just to give you the summary statement, as I told you, if in within your particular whole network, if any traffic that has to flow out will the network channel, the network path will always from switch to the router and then to the outside one. Even the response back will also be the same path. Okay, and also if this suppose if two devices within the same network also want to communicate with each other, they will always connect via switch. Okay, they cannot, there is no way that they can directly communicate with each other. No, there is no way, they will always have to communicate through switch. Okay, so this is what the duty of the switch is. In the and whatever the software that you see in the cloud, okay, those are actually called as a software defined networks. Okay, otherwise software defined networks. Okay, that means whatever the network that we are actually looking currently are called the SDN in the cloud, because everything, all the networking, everything is being created by a software, via website that you see. In case of AWS Azure, this is actually a website running, and it is creating some kind of a virtual networking environment using some using the software that is your website and all. That is the reason why all those networking components are called as a SDN, software defined network. So when you go to the Google and you search the and when you type the term software defined network. Okay, when you search the term software defined network, you see SDN is you will see there is a term called software defined network, which in architecture uploads the centralized network management by separating control plane and data plane. Okay, so there are otherwise in corporate networking. So when you go with the corporate networking, switch, router are the real physical devices actually. Okay, in the real physical, so there are many companies who actually create the real physical devices. Okay, you see the switch and routers are the real physical devices, and each of the ports that you see. Okay, so each port actually shows up. You can pull up Ethernet cable from here and can plug to each of your devices, and this is how your devices close. Okay, and one more thing, this particular device, when this particular network path that you see is also called this LAN. Okay, this is also called as the LAN networking. Okay, and this outside one is called WAN, that is the wide area network. Your internet is called the WAN, and this is what is called your LAN. Okay, local area network. Yeah, that's all. Thank you so much. Please, guys, if you really like my video, I have a request from you all that please like and subscribe my video and share this particular video as much as you can. Okay, so that more and more people comes to know about the this particular core knowledge. Okay, I'll keep on making this kind of videos so that it actually help you in growing your knowledge. That's all. Thank you.